Let us begin with the contact system. Academic enterprise systems in modern universities are required to manage a massive repository of student profile containing attributes like unique ID, names, academic faculties, and CGPA. The core problem arises when executing standard unoptimized sequential queries during high demand administrative periods, which inevitably triggers critical operational bottlenecks and latency issues. Therefore, the primary objective of this project is to strategically engineer optimized searching frameworks that minimize computational resource utilization and ensure robust system scalability.
Hello, and I am Nur Alasafia, and I will be covering the selection criteria for our searching technique. To guarantee optimal database throughput, several technical constraints were mathematically evaluated. These parameters include search runtime efficiency, data structure, compatibility, specifically regarding sorted versus unsorted array, constraint system scalability, parameter implementation, complexity, and server memory overhead. Based on this rigorous evaluation, linear search, binary search, and interpolation search were selected for our comparative analysis. So we move to my slide, which is comparative advantages. As consolidated in table 2.2, each algorithm presents distinct operational trade-off. Linear search serves as our baseline on our mechanism. It offers maximum structure flexibility since it operates on unsorted collection, but it scales poorly on large-scale database. Conversely, binary search and interpolation search optimize performance by utilizing divide and conquer and predictive positioning strategy on unsorted fields, allowing us to bypass the linear scanning bottleneck during extensive and administrative lookups.
My name is UniSZA and I will walk you through the architectural overview of our system contact design. Figure 3.1 illustrates the contact diagram for the purpose optimization system. The system interfaces directly with one primary external entity, the university staff or administrator, and a backend student database. The transactional data flow initiates when the administrator inputs a search request. The centralized system then intercepts this request, processes the input query against the database index, and structurally returns the matching student profile back to the administrator interface. To support this architectural workflow, the system is engineered across 5 cross-functional modules. We have the search request module for user input processing, the search processing module which handles the algorithm routing, the student database module for transactional record indexing, the result display module for clean data presentation, and finally, the optimization module to ensure high-speed processing and runtime scalability.
Thank you, Ani. I am Nurul Ain Izzati and I will present the detailed design and performance analysis, starting with algorithm 1, which is linear search. Linear search utilizes a straightforward sequential traversal mechanism. As shown in the pseudocode, the algorithm deploys a standard for loop to sequentially evaluate every entry in array A from index 0 up to n-1. If the student ID property matches the targeted input key, the routine instantly terminates and returns the array index I. If the dataset is fully traversed without satisfying that condition, a sentinel value of -1 is triggered to denote that the record does not exist. Moving on to asymptotic analysis in table 1, linear search demonstrates a base case time complexity of 0, 1, which occurs when the target record is positioned at the initial index. However, because it evaluates elements sequentially, its average and worst case complexity scale linearly at 0 and when the target is at the final boundaries or entirely missing. On the plus side, its space complexity is highly optimal at a constant 0,1 due to its iterative in-place execution model. Next, we analyze algorithm 2, which is binary search, which introduced an optimized divide and conquer paradigm. Unlike the sequential approach, binary search strictly mandates that the student record array be pre-sorted. The logical framework initializes low and high pointer boundaries. Within the while loop, the algorithm continuously computes the dynamic mid-index. By inspecting the center element and shifting pointers accordingly, the system effectively eliminates 15% of the active search pool during each individual loop iteration. Like in Table 2, this systematic division provides massive efficiency gains. While the base case remains a constant 0,1, the growth rate for both average and worst case scenarios is tightly bounded within the logarithmic complexity class of 0 log 2n. This mathematical guarantee ensures that the system processing time remains exceptionally low and highly scalable. Even if the university database expands to millions of student logs, while maintaining an optimal 0,1 auxiliary space overhead.
Assalamualaikum warahmatullahi wabarakatuh. My name is Rohana, Binti. My ID number is 0851560. So for today, I would like to present our project topic titled System Contact Design and Comparative Performance Analysis for Student Record Search Optimization. For this project, we are focused on improving the efficiency and currency of searching student record in a university database. We selected three searching algorithm, which is linear search, binary search, and interpolation search. In my part, I will explain about interpolation search and the conclusion of our project. So for interpolation search, is used for searching sorted and evenly distributed user ID or student IDs. Unlike binary search, this algorithm estimate the target position first, which is had to make a searching process faster and more efficient. For the performance analysis, the base case complexity is 0,1, where the record is found immediately. The average case complexity is 0 log n, which is very efficient for evenly distributed data. However, the worst case complexity is 0n when the data is unevenly distributed. For the space complexity is 0,1 because the algorithm only use a few extra variables. In terms of scalability, interpolation search is suitable for less student database and sometimes perform faster than binary search. However, it is least effective for randomly distributed. And for the conclusion, the student record search optimization system is improve the efficiency and accuracy of searching student record. Linear search is simple but most powerful for large database, while binary search is faster to sorted data. Interpolation search is provide the best performance when the data is evenly distributed. Therefore, binary search and interpolation search are more suitable for handling large student database. That's all from me. Thank you.